Hello. So we are here at our last meeting with the review. Let's see what you guys have. Hello. Oh, all right. So, I would need specific examples. This is the review section when you ask a question, right? You don't want me picking the questions. So, give me the problem that we should work on. Okay, 5. 15. Let's see what that gives. Now, if something is too crazy for the exam, we'll just skip it. Sorry, we couldn't open your course. Why? My MATLAB is not opening. There it is. Study plan. All chapters. Chapter 5. 5. And you said problem 15. This one. Yeah, this might be too long for regular exams. Let's see. So we have x prime is equal to 411 negative 9 10 3 007 x with an arrow. All right, so we start with the standard 4 minus lambda, negative 9, 0, 1, 10 minus lambda, and then 0, and then 1, 3, 7 minus lambda. And we need absolute value because we are calculating determinant. That's 4 minus lambda times 10 minus lambda times 7 minus lambda. And then minus 0, so we don't need this. And then we have plus 9 of 7 minus lambda minus 0, we don't need that. And then the last one is 0. Okay, so all of this needs to equal to 0. Now there is a very quick hack way to solve this. You see that 7 minus lambda is present in both. So we can factor 7 minus lambda, and in these parentheses just multiply this and then do plus 9. So that's going to be 40 minus 14 lambda, and then plus lambda squared, and then plus 9 equal to 0. And you have 7 minus lambda, and you get your 49 minus 14 lambda plus lambda squared equals 0. And this one now, 49, that's a 7 squared, and then 2 times 7 is 14 with a negative, so this becomes 7 minus lambda cubed equal to 0, from where we get that the lambda is 7 with multiplicity 3, meaning that there are 3 of these guys. Now there are multiple ways of dealing with these repeated eigenvectors and eigenvalues. Depends which way you want to solve this. Let's go and do the lambda for the first. So our lambda is 7, right? So you will be subtracting 7 from 4. So we'll get, all right, so what do we get? We get 4 minus 7, that's negative 3, negative 9 and 0. Then we get a 1 and 3 and 0. And then we get 1 and 3, and then 7 minus lambda, that's 7 minus 7, that's a 0. Oh, these are supposed to be regular matrix times A, B, C to give us 0, 0, 0. There we go. So that's what we have for our matrix in terms of, right, for eigenvectors. So we do have our eigenvalues, which are 7. I'm just gonna get this problem off and see if you guys are. Just need to put the chat on the side. Give me 1 second to rearrange stuff. There we go. All right. This way I have everything. All right. So now we are supposed to solve this, and as you can see, all 3 equations are the same. All of them are the same equation because they don't. If you divide the top one by negative 3, you get also 1 and 3 and 0, right? So you can just say 1a, oh, come on, tablet, a plus 3b plus 0c equal to 0. So your job is to pick a, b, c, so they add to 0. So if you pick a to be 3, you pick b to be negative 1, and you can pick c to be literally anything, right? Because it's going to be multiplied by 0. You can put 0, you can put 1, it doesn't matter. You pick anything there. You are going to get your vector, right, for this, and that's it, right? So now you are you have your vector v that is associated with your lambda. So now the question is, well then, right, how do we get the rest of the vectors? Because we can have more vectors. We need 3 vectors, right, because we do have 3 eigenvalues. They're all the same, but we need 3 distinct, 3 independent vectors. Yeah, my terminology today is not working. So we need 3 independent vectors to figure out, right, all of this. So now what you do is you can calculate the square of the matrix. So you would calculate, now this is where it becomes now, well, I'll do 3, 0, 1, 3, 0, 1, 3, 0 times 1, 3, 0, 1, 3, 0, 1, 3, 0. and when you multiply that, you will get a new matrix that you can look into. So now 1, 1, 1 into all of these will give us a 4. 1, 1, 1 into all of these will give us a 4, and that will us a 4. So now 3 and 9 is 12, and that's gonna give us 12, and then 12, and then 0, 0, 0, and you are still getting the same matrix back, as you can see when you divide each row by 3. And now this is the case where you go into what do you call it, multiplying with the vector, right, to come up with another vector where you use the old vector, so we can have, now again, this is going to be a plus 7I times vector v you already found, right? And that's going to multiply all of the values by from the matrix A, and it's going to multiply it and get it. It's just, the problem is too long for you know, on your exam you can expect 2 by 2 matrix. This would take literally another 20 minutes to solve. Well, not 20 minutes, but this problem like this with a triple eigenvalue, when they're defective and you have to find it, it's way too long. So it's not good for an exam. You can finish this one by multiplying and just finding another 2 vectors. It's not very quick. It's simple, but it takes long time, and the problems with the triple eigen values are not something that we are going to deal with. So the double eigenvalue is okay. The double eigenvalue is okay, like the one you had on your exam, and obviously that will show up on the final if you're taking the final. I mean, it doesn't have to be double eigenvalue, but the eigenvalue problem is on the final. So whether it's going to be real, repeated, or complex, that's a story. But so that problem, there's somewhere in the book, let me just see, 5.5, the procedure you can follow. Eigenvalues on lambda 0, lambda 1, lambda 2. Yeah, you can follow example 6, for instance, if you want to follow. So page 344, 355, 345. Yeah, 344, 345 page in the book. You can follow that one to finish it off, but it's the same calculation. As I said, a little bit too long for the test. What else is there? Could you go over some examples from chapter 7? Yes, as soon as I get the examples. Oh, there is a chapter 7 example, 739. Let's see, 739. Again, if it's something that is going to use partial fraction decomposition into tomorrow, we're gonna cut it and then call for a different example. 739. There we go. 739. Apply the translation theorem to find the inverse Laplace transform for the following problem. So again, using one of those formulas, if the problem can be, so you know, on the exam I don't have to be this specific and say, okay, use exactly this property. If it can be solved in any other way, I would be fine, right? But so f of s, this is 739, is 7s plus 11 divided by s squared minus 10s plus, who came up with the 74? All right, so they want to use the translation Yeah, apply the translation theorem to find. Okay, so translation theorem was the one where you are subtracting the value from S, right? And that gives you just multiplication by E. If you, I don't know if you remember or not, but Laplace transform of e to the at times some function f of t, which you are function that you are looking for, is just f of s minus a. And if you apply inverse Laplace to both sides, then inverse Laplace of f s minus a is going to be e to the at f of t. So this is where they want us to use the inverse Laplace. Now this is again a problem that is very possible for either exam 4 or on the final, and you guys again are picking which one you want to take. If you want to take both, I mean, go ahead, but it's advisable to just pick one. They're going at the same time, both are Sunday through Tuesday. The first order of business is to factor denominator, and what I'm actually going to do here is I'm going to do completing the square on the denominator right away, because you know chances are that I'm not going to find the factors of 74 that are adding to 10 and so on. So I'm just going to do quick completing the square and see what the translation is. So from here, for the completing this, come on tablet, is going to be s squared minus 10s, and then I have to do plus 25, and then I have to do minus 25, and then plus 74. So you take half of 10 and square it, right? So half of 10 is 5, squared is 25. So these three together are s minus 5 squared, and then I have plus, and then over here I have 49, right? That 49? That looks like 49 to me. Yeah, if I do plus 5, then it becomes 79 minus 30. Good. All right, so now I have the new denominator for my f of s, and I have 7s over s minus 5 squared plus 49. You can also write it as a 7 squared, plus 11 over s minus 5 squared plus 49. Now, what's happening here is that we have the one that is giving us a cosine and one that is giving us a sine, right? But the coefficients and constants are off, so we have to fix those. So this over here is telling us that we have to multiply by e to the 5 negative 5t, right? That's what is telling us from the parenthesis, because you can see here that when you have a negative a in here, you have the positive a on this side. So negative a, oh, oops, I had it right the first time. I don't know why I switched it. So negative a in the f, right? But I don't have all of the features of that, because I do need s minus 5 on the top as well. I should have stolen from 11, but we'll have to fix that. So when you are dealing with these things, right, your s needs to be subtracted as well. So we have a little more algebra witchcraft to do before we can just claim our solution. So on the top, right, on the top, I need s minus 5, right? So let's go and just fix that now. Let's fix our coefficients. So this is what I have. On the bottom, I have s minus 5 squared plus 7 squared, right? Now, the 7 squared will be important for the second one. Now, for the first one, what I need is 7s minus 5, right? But I can't just say my s minus 5. I have to put also plus 5 in the parenthesis, and then this will escape the parenthesis in the next step. Plus, we know the trick. Kick 11 outside. Over here, we have s minus 5 squared plus 7 squared. I need 7 on top because it needs to match the k value. So I need the 7, so I have to divide by 7. Maybe I should, let me use a different color for the things that I fudged. Right, so I need a 7 on top, and then I have to divide it by 7 to counter it. And over here, I fudged -5 and then +5. So these are the two things that I had to fix to match it to what I have for the inverse Laplace. So now I have f of s is equal to, now I have on top 7 s minus 5, and then I have plus 35 that are unwanted, and then I have s minus 5 squared plus 7 squared on the bottom. And now see, this plus 35 will create another one of those to throw away. And over here I have 11 over 7 and 7 over s minus 5 squared plus 7 squared. So now break the first one into 2 again, and then combine the second one with the one on the right. So I have, oh, I should have done that earlier, whatever. 7 s minus 5 over s minus 5 squared plus 7 squared plus 35. See, this is bad thing, because I went through all of these calculations here, where now I will be adding 11, and then I have to mess with the common denominator and so on. So this was a bad call to actually deal with this stuff. I'm going to leave it as 11 over 7. Sorry, 11 over the fraction, because now I will be adding 35 of these to the 11, because they have the same denominator. So 35 plus 11 is 46. So I have a 46 of these. And then I have s minus 5 squared plus 7 squared. And now we can fix that one. Now the first one is set. I don't need to do anything with the first one. Kick 7 in front, and s minus 5 divided by s minus 5 squared plus 7 squared is normal, right? Nothing to do there. That's just the cosine, this one, right? And it's e to the 5t times cosine. So that's a basic one. Now plus, and this is where I go 46 over 7, and then 7 over s minus 5 squared plus 7 squared. So for cosine, you want to have s. For sine, you want to have k. And that is given on the chart if you take a look at the front of your book. So now what you have here is f. So now we are going to hit this with the inverse Laplace. Your f of this brace is terrible. So f of s turns into f of t. And you have 7e to the 5t cosine 7t plus 46 over 7e to the 5t sine 7t. And that should be it. That should be the answer, because we already have, so s minus 5 makes the translation, right? Which is why we have this term multiplied into cosine. And then the standard s over s squared plus 7 squared is the one that gives you cosine 7t. But because s was minus 5, then you have e in front with the 5 to the t, and then there was a 7 in front also as well. So this is how we use the translation. It's a little bit tricky. So why we didn't, well, probably we didn't need to. Some problems are, usually introductory examples are lined up nicely. I remember we did have very few, but I might have done only one problem for translation or so on. You're not changing the numerator. You are transforming it so it fits the rule. So we can do the inverse Laplace easily looking at the chart. So the problems that I've done in class might have been like introductory examples where the numerators are already lined up nicely. So lining up the numerator is always as easy as, a little bit of either completing the square, splitting the fractions, or multiplying and dividing by a constant, or as you see in adding and subtracting a constant. So this is the fudge part over here, so I'll put that in orange. Me getting a 7 here, so I can do this. And there was another plus and minus 5 up there to make it. All right, cool. Is there anything else that you guys would like to work on for the review? The answer is always yes. The question is which one. I don't want to pick problems because you are expecting me to pick a problem that is close to the one that it's on the exam, and that's teaching to the exam, which means you're learning nothing. You have to pick a problem that you are struggling with, and I will provide the answer to the best of my abilities, meaning, right, if the problem is something that I can solve quickly and it's appropriate for the test, right, I will let you know if it's too long, like I did for the first one, way too long for the exam. The question is even if you would see the shortcut to factor and all of that kind of stuff for those lambdas and so on, so that problem can turn into a living nightmare of calculations, especially that you have to do squaring and cubing and all of that stuff. So just give me a problem and I will answer. Now, in general, series problems are the longest on the test. They've always been. So some of the rules that I would have for other problems, like let's say there is no reason to go crazy and do a 3x3 matrix with lambdas when 2x2 is just fine with the moderate calculation. You cannot make power series problems short. They cannot be made short. So as much as I say, yeah, we should be able to do 4x4 matrices and 5x5 matrices by hand, fine, right? But that's when you have our extra. But I have an option to make lambda problem shorter. I don't have an option of making the power series problem shorter. So that is the difference between the two. Now, we have the first question here coming for the power series. And we have the solution for y prime plus 8xy equal to 0. So in general, I'm not sure if they mentioned that in a book or not. We understand the first order's equations very well, and we pretty much never, right, use power series because we have so many other ways to solve differential equations. So differential equations that are second and third order are generally the ones where you hit them with a sledgehammer called power series. Now, this problem you might be able to solve with other methods. One of the methods that should immediately pop out as a possible way of solving this problem would be separation of variables, because you can quickly separate these variables because it's equal to 0 on the other side, right? So you can I know it's a power series problem, but I just want to stress out because sometimes, not sometimes, pretty much all the time on the final exam, I give a first order equation and the second order equation, and then I just ask you to solve the same equation using different methods, which actually helps you at the end knowing that all of them have to have the same answer, right? So you have 3 problems with a, right, let's say, first order equation, and it's just solve it 3 different ways. Okay, great. That's perfect because those 3 problems should all have the same answer at the end. Plus minus a constant that gets absorbed here and there. And then the same for the second order, right? Where I can ask you to use 2 or 3 methods, right? Because you can always solve problems with Laplace and power series. And then additional method could be, what you learned in chapter 1, 2, 3, and so on. Then there are systems there. Just so I can literally put a second order equation on the, first order, ask you to solve it in 4 ways, and the second order equation to solve it in 4 ways, right? So there are those. Okay, now enough mumbling there. You can use integrating factor here. You can use integrating factor as well. You can use separation of variables where you say dy dx is equal to negative x 8xy, and then you go dy over y is equal to negative 8x dx, right? And there's your separation of variables. You hit both sides with the integral, right, in the head, and there you go, right? So there is no reason to use a sledgehammer and do the power series when you can do the most fundamental basic, right, idea that you learn in Calc 2, which is separation of variables. Now, the problem might say, like the one on the final, solve this problem using power series. All right, fine. So you assume your power series, as always, 0 to infinity cn x to the n, and then you take your y prime to be 1 to infinity n cn x to the n minus 1. Now, we are not going to shift anything here because it's multiplied by x in front. So I'm not going to do any shifting. I'm just going to just put this and this over here so you know what to do. There we go. Those are instructions. Okay, so now I'm going to place all of this into a single series and then see what I need to do. So this is n minus 1 here. Plus summation of 8 cn x to the n plus 1, 0 to infinity, all equal to 0. So x was added to the other x, created a plus 1, and I have 8. Okay, so this is it. Now, if I shift the counter on the first one, I'm going to go into an x, right? Because when you shift the counter back to 0, you get n plus 1, you get cn plus 1, and you get x to the n. Plus, this summation here is 0 to infinity, and you're getting your... Okay, so this one is 8 cn x to the n plus 1. All right. Now, what I can do is I can shift the counter one more time to align, because it's more important to align your x's to have the same power, because when x's have the same power, you can then peel off the terms, right, to match the where the series starts. So I need to see what I can do here. If I can go and say n, so which one do I want to shift? It's gonna, if I say that m is equal to n plus 1, and this is n equal to 0, I'm trying now. So hold, right? So if I add +1 on both over here to make it m equal, it will be m equal to 1 in that case, because I'm adding 1 to create m. N, so that's going to be, so now what is this changing into? It's changing into m, which starts at 1, and then there is infinity, and then 8, and this is going to be cm minus 1, and then x to the m. Okay, so that looks like it worked. Because you can shift forward or backward, right? Depends on which one you need. Rename these to n's. So 0 to infinity, n plus 1, cn plus 1, x to the n, plus summation n equals 1 to infinity 8 cn minus 1 x to the n equal to 0. Now, I have my x's with the power matched, but I don't have these guys matched, which means I have to peel one term in the first one. So I am peeling one term here, and that's the term 0. So that's 1 c1 times 1. So 1 times c1 times x to the 1 plus, and the rest of the series starts at 1 for ever. And now you see that both series start at the same value and have the same x to the n. So now I can combine those. Now the first term over here is just c1x. There's nothing there. Plus, and now this is mushed into a same series. And that series is, we have the bracket, we have the n plus 1 times cn plus 1 plus 8 cn minus 1, and then x to the n equal to 0. Now, in order for this to equal to 0, right, we need this whole thing to be 0, and this thing to be 0 here, where we get that c1 is 0. So what do we get here? We get recursion n plus 1 times cn plus 1 plus 8 cn minus 1 is equal to 0, from where cn plus 1 is equal to negative 8 cn minus 1 divided by n plus 1. And you can see this negative 8, right, being a same factor like when you did this one, right? You had a negative 8 floating about. So you know that this is, right, at least roughly okay. And your counter now over here starts with n equals to 1. It's no longer starting with 0 because, right, you kicked this term outside. Now this c1x needs to be also equal to 0. Now if that means that c1 is 0 because your x is not supposed to be 0, like here x to the n is not supposed to equal to 0. So you get the recursion and you get this formula. So now when n is equal to 1, you get your c2, and that's great because your c1 died over there. You get your c2, and your c2 is negative 8 c0 divided by 1. So that's just negative 8 c0. When n is equal to 2, you get your c3, and a c3 is negative 8 c2 divided by, no, c1 divided by 2 plus 1 is 3, but that one worked out to be 0 because c1 is 0. And then for n equals to 3, you get a c4. c4 is negative 8 c2 divided by 3 plus 1 is 4. and that's going to be our negative 2c2, negative 2c2, which is equal to negative 2 times negative 8c0, right, which is 16c0. N equals to 4 gives us c5. c5 is negative 8c3 divided by 5, and that is equal to 0 because c3 is 0. So now you see that you get every second term is surviving. So c6 is negative 8c4 divided by 6. That is negative 4 over 3 when you cancel. Not supposed to cancel, but such is life. And then you have a 16c0 here. And you know what? Negative 64 over 3. I somewhat smell that 4 to the n something divided by whatever times c0 and so on. So what do we have as a surviving here for our, right? We have y equals, and then I have my coefficients. These are your powers on x's that you have to add to your terms. So the first surviving term is negative 8c0 and then x to the first. So negative 8c0 x to the first. The next surviving term is x cubed, so 16c0 x cubed. And then we have the next one is minus 64 over 3 c0 x to the 5 plus ... it will go forever. Now the problem tells you keep 3 terms, keep 5 terms, keep 11 terms, right? So usually it's keep 3 or 4 terms. I already have 3 terms, so I mean n equals 7 would be the 4th one, right? So you can simplify this a little bit by y equals, you can kick out an 8c0 or negative 8c0, and you are left with x minus 2x cubed. You can actually kick one x out as well. Yeah, whatever. It doesn't matter. Whatever you do, just, you know. So there's the power series answer to this question, but then this problem can be done by, should be able to do it by integrating factor, and should be obviously able, which I did almost everything up there with, dare I say, simple separation of variables. So yeah, there's the power series question, and again, you're using a sledgehammer on a problem that we literally I know you were asked to, but as I'm saying, we are not supposed to use the sledgehammer on a problem that we can do literally by the first lecture we learned this semester, which is separation of variables. Now again, if you're taking the final, this is exactly what you expect. Something like this, a problem that is asking you to do separation of variables, Laplace, and power series on the same problem. And then second order problem, boom. Do the, the R method, the characteristic equation. So do the characteristic equation, or maybe separate into multiple equations for eigenvalue problems, do the Laplace, do the power series, right? So it is very simple to come up with, 4 problems, but then part A, B, and C, and D inside, right, to solve it 4 different ways. And then have so there will be 2 problems, right, for first order and the second order, 1 each, which has 3 or 4 ways to do it. And then we just need 1 problem on, population, maybe 1 problem on springs. It's very structured. What else is there that it's cool? Eigenvalues, right? But then you get that through systems, so you can get a second order equation. You convert the second order equation into a system of 2 first order equations, and then you create a matrix, you use eigenvalues, so you can solve the problem using characteristic equation, eigenvalues, Laplace, and power series, right? So characteristic equation, system, Laplace, power series for the same second order constant coefficients. So a lot of cool things that you can do. And again, going back to the first problem today, that's a 3x3 system, so there will be a triple derivative equation, right? If you are to mush it somehow back into the original problem, I mean into a third degree problem. But when you solve a second order differential equation with constant coefficients, when you convert it into a system, you will get a 2x2 system. And if you have a repeated eigenvalue, you just have to do one calculation instead of doing 3. So that's something that reduces the problem. And as I said, as much as I can't make any of the power series shorter, I can definitely make the eigenvalues problem shorter by giving you 2x2. You have 2 hours for the test. If I take 30 minutes on unnecessary 3x3 matrix, then you don't have time to mess with power series, right? So there's that. Anything else? And if that's a no, I'm gonna go back, grade your exam 3. So my goal is to post exam 3 grades latest tomorrow. Latest. If I manage to finish it off today, I will. I am behind on my schedule because my plans are always skewed back with homeschooling with the kids and stuff like that. I had to do some stuff, and then also I had 2 algebra exams to grade yesterday. I thought I'm gonna be done a day early, but it ended up so I literally graded only 2 exams for your class as of noon on Friday today. So I'm just gonna go crazy for the rest of the day and tomorrow until I finish it to post those grades. So if you don't see on Canvas the grade for your exam 3 today, don't panic, you should see it tomorrow at some point in the day. And also the unnecessary emails are, people are not reading announcement, people are not downloading the new syllabus, right, to see that the assignments have been changed since the first day and asking me about assignments that don't even exist anymore. Then I have to waste time to explain to those people, things that they should have read. So that pushes everything back. Obviously, there's an insane amount of doing that, especially for algebra class. But you guys are not immune to that either. I did get some emails about even I got an email about the project. We scrapped the project a month ago, and then I came up with the new assignments 2 weeks ago. I posted the announcement. I posted the syllabus. And I'm still getting emails about it. All right. Yes, there is no project this semester for because of the stupid situation we're in. So you guys have, because I can't have you going around doing measurements, going to labs, going to baking and stuff like that. I mean, you could do baking because you're sitting home all day long, but again, I don't know if you can find a $4 chicken or $5 chicken in the store to bake, to do Newton's law of cooling for differential equations. So I changed to the paper, and I changed to that course survey on MyMathLab. So those 2 assignments, and I clearly stated that all of them are due, right, the midnight of May 12th. And I'm still getting questions. I don't know what else to do. Anyway, okay, so let's see. There's another one, and it says, use integrating factor to solve. Holy nightmare, really? I know we can solve this by separation of variables, but can it be done with integrating factor too? This is, as you heard my reaction, holy, right? And then I totally did not say nightmare after that, because, yeah, this is something that you are not going to go anywhere close with integrating factor. Plus, this doesn't look cool for integrating factor at all. Does it work for separation? Does this work for separate? Oh no, it says solve by integrating factor. I know it can be done by separation, but wait, you're not making sense. You're asking two different questions for the same thing. And at first post where the problem is, you say do it by integrating factor, and then the second one you say I know it can be done by separation, but can it be done by integrating factor? Well, if the problem is supposed to be done by integrating factor, then clearly it should be, right? But anyway, x squared plus 25, we use dy dx if we're going to do the separation, and x minus xy, like this, it doesn't look cool. Like this x over here doesn't look cool. Maybe there was a mistake, or maybe, anyway, because this can be written as x squared 1 minus y, right? So if you have that, then the problem, right? If you factor out this extra x, given that this is copied correctly, like, it looks fishy to me, right? That's what I want to say. This looks fishy, so it's either this is 1 or these are 1s. Like, something might be 1 there, but I don't know. If this is exactly the way the problem is, that's fine. Let's try it. But so dy is going to be over 1 minus y, and on the other side we have this x that survives, x squared, and then it's going to be divided by x squared plus 25, and then we're getting dx. So separation of variables is not a question here. It's easy, cheap, right? We have a basic integral here. On this side you get that negative ln. On the other side you are going to use your powers of trig sub to solve this integral. So this should not be an issue for separation of variables. Now, integrating factor. Integrating factor is requiring you to have everything in the on the same side. So x squared plus 25 y prime minus, and I'll just put this as x squared Aha! For integrating factor, I actually have to fix this as x squared minus xy, x squared y, and then plus x squared y will be here, and on the other side we'll just have x squared stay alone. Yeah. So y prime, remember you have to have nothing here, right, in order for integrating factor to work. Oops, plus you get your x squared over x squared plus 25y equals to x squared over x squared plus 25. Remember, your you cannot make x squared plus 25 to be a 0. So you have your integrating factor equation set. Now, to do integrating factor on this one might not be the best. Really, I just want to check one thing over here. Got it. So page 49 in the book is where they have a closer look at the integrating factor method. They clearly say y prime needs to be alone, as I did, plus p of x y equals q of x. So now you clearly see what's p, what's q, right? You have to have that. Yeah, looks like I'm either allergic to integrating factor or you. It's one or the other. Anyway, we are supposed to solve this e to the integral of p of x, right? That was now I used mu, they use rho, just to be annoying, I guess. So we solve that one. Let me just see one more thing here. So yeah, that's that. All right, so we have E, and now you have to do your trig substitution here. Now, I am going to use wolf on this because I don't want to stay here doing the trig sub in the problem. This might be definitely too crazy for the exam if you have to go through trig sub and so on. I should be scrapping this problem right now. Squared divided by squared. Just want to see if I'm going to end up with anything that it's actually easy for this one. And when I integrate this, we get, yeah, you just get a huge mess. Rho of x is equal to x minus 5 inverse tangents of x over 5. So this is what you are supposed to multiply into everything. So y prime times x minus 5 inverse tangents of x over 5 plus x squared over x squared plus 25y times x minus 5 inverse tangent x over 5, and then on the other side you have x squared over 20 x squared plus 25. Yeah, so this is something that you are not going to do on the test. 5 inverse tangents x over 5. Once you have this side is supposed to condense, and then once it condenses, then you are supposed to integrate both sides and go from there. So you will have integral of this mess here. So this is definitely something that it's nowhere close to. Can you use partial fraction decomposition? Hell no. Partial fraction decomposition cannot be used here because you only have one factor. Partial fraction decomposition needs to have at least two factors. So x squared minus 25, okay. X squared plus 25, hell no. Because this one factors into x minus 5, x plus 5, so you will be using a and b two different linear terms. This one is a single unbreakable quadratic, and if when you set it up like this, there is nothing else to add to it to create partial fraction decomposition. So when you have a single term, a single factor in denominator, right, you can. So you must use trig sub to solve that problem. Partial fraction decomposition is absolutely out of question in this question. There you go. So at this moment I am scrapping this, because once this combines into y times x minus 5 inverse tangent of x over 5, right, and then the derivative is equal to x squared over x squared plus 25 times x minus 5 inverse tangent x over 5. To kill this prime, you have to integrate both sides. So as soon as I hit this, right, good luck. You understand what I'm saying, right? So we are going to scrap this question for, you know, something that is shorter. Now, again, the question is, can it be done at all? I mean, if the question says use integrating factor, then maybe I made a mistake. I don't think I made any mistakes here. But if the question doesn't say use integrating factor, and you are trying to push integrating factor where, as you can see over here, separation of variables is a joke, right? Then obviously we have an issue. I mean, I shouldn't be calling it a joke. You still have to do trig sub on this part. I mean, that's Calc 2. For a DiffEq student, it should be a joke, but yeah, we live in difficult times. Let's call it that way. So yeah, we'll definitely scrapping integrating factor on this problem. Bye, integrating factor. Again, why we have multiple methods of solving? Because some are faster than the others for different situations, right? So in some situations we do want integrating factors rather than, you know, because separation of variables, maybe it's not possible at all. There are also exact equations, and then there are, you can do the graphing for the first derivative, right? First order equations. You can do the slope fields, get the graphs, recognize what the lines look like, maybe do the best fit curve, and obviously Laplace and power series as the sledgehammers. Is there anything else? You can also type in the chat and say go grade, and then I'm just gonna go grade. So on Sunday you will pick between exam 4 or final exam. I will either post announcement today or tomorrow. You will have Sunday afternoon, all day Monday, all day Tuesday till midnight. Your paper is due midnight on Tuesday, and my MATLAB closes the homework, and course survey closes it on midnight. Those of you that are doing homework on a paper, You can send me the pictures, and that's it. I guess my main question. Yes, it could be 0. In which case, if you just get the 0 matrix, this is related to the first question. If you get a 0 matrix, then you can pick literally any vector you want, right? You can pick 1, 0, 0. Usually is the, what people pick, 1, 0, 0. So if you square a matrix and you get all matrix of zeros, you can just pick 1, 0, 0. You can pick 1, 1, as long as it's independent from the vector that you got in your first calculation. So that's the the first question that was. And Jess asks, can I ask you a question about the... send me an email now. I'm not sure what question. You're just supposed to write application of differential equation. What you learned this semester. It's a very simple topic, but I don't know. Maybe there's something else that it's not clear. So the topic is what have you learned in this course, and you just literally sit down and write it. Please do not double space it and make it look retarded. Just get it professionally looking, no double spacing and stuff like that. Double spacing is for your English teachers so they can edit and fix your grammar. Well, we didn't have that problem in the beginning. We did not get a matrix of zeros. We got the same matrix back that we started with, right? So it was a different situation. The one that it's even longer than the one that you are talking about. So I didn't finish the problem. I just gave the page and I said, go look at the page, right? But because I'm not going to put a 3x3 system on the final, you just don't have time. In 2 hours, to mess with a 3x3 systems with a triple eigenvalue, right? If I put a 3x3 system, it's guaranteed to be basic eigenvalues, so that you can just fly through, not a repeated one. So you are expecting a complex and repeated on a 2x2. If you see a 3x3, that means that all 3 lambdas are different, linear, they're like distinct real numbers, and if you're not getting that, you're doing something wrong, because I am not going to ask you to spend 30 minutes on a 3x3 repeated matrix where you have power series and you have the Laplace and you have all of these other things that do take a little bit longer, right? So if I put repeated, right, and I didn't make the test yet because I don't have time, I'm just keep grading and answering emails. If I put repeated eigenvalues, it will be from the 2x2 matrix. If I put. Oh, you can find extra examples online. There are many papers, and they even give the PDF downloads and stuff. You can find tons, but again, you're not going to get... Bernoulli, there shouldn't be anything. Oh man, unless something generated differently for you. There shouldn't be any Bessel, Bernoulli, Euler. Oh, now that you mentioned OpenCourseWare, you can find more examples if you are really hunting for some of the heftier problems. You can go to MIT OpenCourseWare into their differential equations and look at their homework and exams, and you will find more examples because they post solutions as well. So if you go to MIT OCW, OpenCourseWare, OCW, so MIT OCW, go to the math department, undergraduate, you'll see the differential equations is the second on the list because it's elementary mathematics, right? So their lowest level is calculus, and then differential equations is the second course you take at MIT. But they post a lot of problems and problem sets for homework and exams and the solutions to all of those. So you might be able to find a lot of examples there as well. And they have a couple of classes posted, at least 2 or 3, with all of the lectures and stuff. And I think Stanford has the same. Any other problems, guys? Or should I go and continue grading? Anything else, guys? Going once. Yeah, office hours tonight at 9:30 p.m. standard. And that will be it. Nothing on the weekend. I have to catch up with all the grading and stuff. I have pre-calculus exam 3 to grade and calculus 3 exam 3 to grade before you guys are first. I need to grade those 2 classes on the weekend so they know whether they need to take the final in terms of the average for the exam. So I have to focus on those. It's gonna kill my weekend. So I'm going to have office hours tonight and at 9:30 on Microsoft Teams. 9:30 p.m. MS Teams tonight, Friday. 5/8 this year, obviously, 2020. So if you have additional questions, obviously if you have anything in private to ask, you have to send me an email. There are no other ways because obviously this is public and the other one is Microsoft Teams are public, public for the whole class. Whoever joins in is able to talk and share, right, and hear everything. So the only way for us to communicate is through the email if there are any other things other than what everyone should know, right, things like that. All right then, well, this stream 1 hour 20 minutes. We did couple of problems. I gave you the pointers for the final, and exam 4 is just the Laplace and power series, and you pick one or the other starting Sunday. So Sunday, Monday, Tuesday. Office hours tonight at 9:30 if you have additional questions throughout the day. Everything else is due on Tuesday, which is the paper, course survey, and all the homework. Course ends at midnight, and I have a 13th and 14th to grade, post grades, and deal with who wants letter grade and who wants the no credit grade and so on. So that's dealing with. We'll be dealing with that on Wednesday, and there will be a separate post on Canvas in announcements about exactly what. And since the college did a terrible job in explaining all of this, obviously on that page, I've been getting requests from students who are failing courses. You know, they are requesting the pass grades. I'm going to post exactly, right, grade earned. So I will say if the grade earned is A, your option is to keep A as a letter grade or to keep A as a pass no credit grade, which means it won't be calculated in the average, which would be stupid to do, but you can. If the grade is B or B plus, you can choose, well, also C plus, you can choose to keep the letter grade as is, calculates in the GPA, or take pass grade, which does not calculate in GPA. All of these grades, right, C plus, B plus, and A, allow you to graduate, allow you to transfer the credits, and all of that stuff. If your grade is D, you can keep letter D as a letter grade and graduate, but you can't transfer it. You can also take a no credit grade, so it doesn't impact your GPA, and still graduate, but you still can't transfer because it's a D. So your P pass or no credit is not changing your letter grade. It's just takes it out of the calculation for GPA. So people that are obsessed with, for whatever reason, they're obsessed with their GPAs, so they don't freak out that, you know, we switched to online and so on. That's the only benefit of those grades. All Fs are immediately converted to no credit. You have to retake the course. Obviously, it doesn't transfer, doesn't. So if you're failing the course, and this is my issue that I'm having, and I'm trying to communicate this to administration, they don't get it. I'm getting students that are failing courses, and it's not just in algebra, in other courses as well, higher level, failing the course with the average less than 50, and say, due to Corona, I'm requesting a pass grade. It's not, you have to earn the pass grade, and then you just choose whether you want to calculate it into GPA or you don't want it calculated into GPA, but you have to pass the course. You have to pass the exams, you have to pass everything, the homework and course survey, you have to pass everything, and the average will tell you what grade A through C, and then you have the choice between pass or keeping the letter grade. If you choose pass, it's not calculated in GPA. If you keep your letter grade, it is. And for Fs, it's not gonna be assigned pass. Now, the college didn't explain that well, and a lot of people are confused, I know, and I gave up on trying to convince them that they did the poor job in explaining it. So I hope that you guys are hearing and understanding this. I mean, you are in DiffEq, so you should be, but it's a mess. Anyway, and that's only for spring, obviously, when we start our summer 1 and summer 2. Any of you taking any courses, this no credit grade will not be there. That's only for the spring semester to compensate for the fact that you did not sign up for the online class and you are forced to take the class online. So that's why this is only the option for the spring semester. In the summer, if you signed up for a course, you know you are signing up for online class, so there will be no pass grades or anything like that. If you score F, it is F. and calculated in your GPA. So, and that's for summer 1 and summer 2. Fall, we don't know yet. I mean, it will be absolutely insane if we, but I don't want to go into that. It's just mess. Bye. See you tonight at office hours, 9:30 p.m. Bye.